array deletion. That is deleting an element from a list of values stored in the data structure array. We will also see the details about searching an element in an array. So we're going to look into two different searching techniques. One is linear search and the other one is binary search. So why I combine this searching with array deletion is like in order to delete an element, we need to first locate whether the element is present in the list of elements given or not. So we need to do some searching in order to locate the element before we try to remove it from the array. So we'll also look into some searching techniques in that case. I'll take an example list and help you understand how an element from the array can be removed. So let's take an example list like say 44, 55, 66, 77 and 80. So here we have coming to deletion an array, we have two different cases to be handled. So the two cases that need to be handled are, first one is check whether the element that is to be removed are really present in the list or not. So check whether the element is present. So only if the element is present we could remove it from the list, or otherwise it is not possible. So you have to say that the element is not present. The intended element, the element that is intended for deletion is not available in the list. So that has to be informed to the user. And the other cases, so if the element is present, then you need to delete the element. So if the element is present, then we should know the location of the element in order to remove. Supposing that the user is trying to delete an element, say 22. So first thing we need to identify is whether this 22 is present here in the given list of values. So how to do this? So one thing is do a linear search. Check for the presence of this 22 at every position. So what we do is we take the search key and compare that with the very first element of the list. So 44 and this is 22, which is not equal. So we move on to the next position. So this is going to be repeated till we find the element or till we reach the end of the list. So first thing what we do is compare 22 with that of 44. So they are not equal. So move to the next position and now compare 22 with that of 55 and you see that it is not equal. So we repeat this step till we reach the end of the list. So once you reach the end of the list, then we can understand that the element is not found. So in that case we are going to simply inform the user that the element you are trying to remove is not present in the list. So this is what we are going to tell. So and the method with which we try to identify the location of this 22 in the list is called as linear searching method. That is, you go linear, just take every element at each step and do the comparison, check whether the element that you are trying to delete is present or not. So here this is how the linear search works. So I hope the linear search is clear. So take every element at each step and compare that with that of the search key. So if the element is found, then you can simply stop and proceed with further processing. If the element is not found, then you have to go traverse the entire list. So here, if the size of the list is n, then the time complexity is going to be order of n, or the number of comparisons you're going to make in linear search will be n in the worst case. The worst case in the sense, if the element is not present, then you're going to look into every element in the list. So supposing the size of the list is 10,000, then if the element that you're trying to locate is not present, then in that case you're going to check all 10,000 elements, and only then you're going to come to a conclusion that the element is not present. So this is not obviously going to be a good technique when the size of the array is very large. So we go for another technique called as the binary search, which will be explained shortly. So before going into that, let's see how this deletion could be done once the element is located in the list. So if the element is not present, then you're going to simply say the element is not present and you can stop. But if the element is present, then we need to remove it from the list. So let's assume that we are just going to say search for element. Let's assume that the list is 44, 55, 66, 77, 22, 33 and 44. Say 45. So these are the values in the list. Now again we can have two different questions in two different forms. One is delete the key, wherein the value of the element to be deleted will be given in this variable key. So this is one case. The other one is delete element, say at position 5. So we may be given the position from where the element is to be removed. So this is the other case. So one case is given the key, you have to locate the key in the list and then find out the actual position of the key in the list and remove. The other case is the simplest case, that is we will be given the position directly. So if the only problem here is to check whether this position is the valid position in the list. So here the positions are 1, say 2, 3, 4, 5, 6 and 7. So this position 5 is valid in this case. So if the position is something like 10, which is not here in the array, then we can simply say that the position is invalid. So this could be checked with the upper limit of the array. So you can just have the upper limit and lower limit, and you have to check whether this position falls in the range of the array index. So if it falls in the range of the array index, then you're going to simply go remove it, or otherwise we'll say that the position is invalid. So these are the two cases. Let's take that we are given the key to be removed. Say 22 is to be removed. So how can we remove this 22 from this array? So it is very simple. So you can simply do a linear search and find out this 22 is present, and it is present at position 5. And if this is position, and if you want to have the index as say starting from 0, right? So here it is at position 5 or at index 4. So now we know the location from where the element is to be removed. So the next step is how to remove it. Can we simply just remove this by deleting this and having the value 0 here? No, it is not possible, because 0 can also be one of the elements in the list. So this 0 will be the new element at position 5 or at index 0. So which is not valid. So we say that if you simply remove it and do nothing in that position, then you're creating a hole which is not acceptable in arrays. So what we have to do is we have to just refill this position with the element from the next position. So take this 33 one position up. So in which case this position or this location becomes a hole, which is again not acceptable. So you have to move this 45 to the place of 33, and this position 45 should be marked as null. So this marks the end of this null marks the end of the list. So here we have to simply move the elements one position up and fill that position, and this position from where you remove the element cannot be left blank or empty, which in turn creates a hole and it is not acceptable, right? So here the point is very clear, simple and clear. The thing is, you have to identify the location from where the element is to be removed, and once the location is identified, just start moving the element one position upward at every step till you reach the end of the list. So it is as simple as that. Find out the location, start moving. So here the movement is going to be upward movement of data. Right? Here again the problem is, say if you want to remove the very first element, and if the size of the list is say some 10,000, and remove element at position 0 or 1, then again the number of data that need to be moved is very large. So this is the major drawback with array deletion. So having a hole in between the list of values is not allowed, so we have to deliberately move the elements one position up till you reach the end of the list. And if the size of the list or array is very large and the deletion is going to happen in the very beginning of the list, then the number of data movement is going to be very, very high, which is a major drawback in array data structure. I hope you understand how this deletion works. So just find out the location, find the key, check the presence of the key. If the key is present, then try to understand the place where the key is, and from there on you start moving. So this is going to be very simple. Say you just get the key to be deleted. So key to be deleted, right? So just search for the key, right? So which is going to get you the location of the key. Say for example I is the location that is returned by this function search key. So here the next step is while so in our case this I will be 4. So here in place of a of I you have to move a of I plus 1. So while I is less than n minus 1, you do this, right? So at every step you also increment I. So this will actually keep moving the elements till you reach the end of the list. So we start from position 4. So I is 4. What is n minus 1? It is 6. So you just move a of 4 with a of 5 and make I as 5. And in the next step again you go, I is still less than 6. So you just move a of 5 with a of 6. Now you go in, you increment I value, I becomes 6. Now you go back and check whether I is less than n minus 1, which is 6. So here condition fails, you come. So you simply move 33 and 45 one position up. So this will get you the job done. Now let's see how the binary search works. the binary search to work, we have an initial condition. Here, the initial condition says that the list must be sorted. So for the binary search to work perfectly, the list of elements that we actually take for searching must be sorted. This is most important. So here the list what we have taken already, say this a list of elements 22, 33, 44, 55, 66, 77 should be in sorted form like this. So if the list is not sorted, then this binary search is not going to work, right? So here I'll just write the index. You'll understand shortly why this list must be sorted for the binary search to work, because so yeah, how this binary search is going to search for an element is, we'll just try to apply the algorithm technique called as divide and conquer. So it actually tries to divide the list into two and check at which part of the list the key that is being searched falls. Say for example, you try to search the value 33. Now how this binary search works is, it will just try to find the middle position of this list. So the mid value will be computed using low plus high divided by 2, whereas where low is 0, high is 6. In general, low is 0 and high is n minus 1 to start with, right? So now in this case, we take the mid value as 0 plus 6 divided by 2, which is 3. So here this element is the middle element. So this is the mid value. Now how this binary search checks is, you'll just try to find the middle position and take the value from the mid position. This A of mid will be taken, supposing this array name is A, then A of mid will be taken and that will be compared with the key value. So if this is equal, then we are done. If this is true, then we are done, we can stop. But in this case, we are looking for the key 33, whereas A of mid is 55 and the Cartesian fails. But we can understand from this comparison, we can understand that 33 or the search key is less than that of the middle value. So once you understand this, then it is not necessary to take these values in consideration anymore for searching, because we know for sure that all the values that are coming after this middle position is going to be greater than that of the middle value as the list is sorted, right? So in this case, we try to totally discard this part of the list, right? So this part of the list is not going to be considered for searching anymore. So the remaining set of values, that is 22, 33 and 44 alone will be checked for this key value 33. So now since the middle value is greater than that of the key value that is being searched, now the high position must be modified. So high should now become mid minus 1. So low value remains the same, we are not going to change the low value. So here, to make it very clear, if key is equal to A of mid, or if A of mid is equal to key, then done. What are the other cases possible? Else, if key is less than A of mid, then change high value. This is one case. So what is the other possibility? Key be greater. Either it should be equal or lesser, and the other case possible is being greater. Else, if it is greater, then you're going to, if the key value is greater, then it is going to appear somewhere here, not here, right? Either it should be here or it will not be there in the list at all. So in that case, what we have to do is we have to modify the low value, retain the high value as it is, modify the low value. So low is going to be mid plus 1, because mid value has already been compared with that of the key value, so we know that it is not equal, so we need not check it again. So you just change the value as mid minus 1, high value as mid minus 1 if the key value falls in the left hand side of the list, or else low value is changed to mid plus 1, right? So now in this case we find that the element 33 which we are trying to search falls in the left part of the list. It is here, it should be here. So what we do is we have just modified this high value. So now again repeat the same. So what is low value? Low value remains the same. Low value was not changed. The initial value in low was 0 and high was n minus 1, right? Now as the key is less than this middle value, we are going to change the high value. So low remains 0 and high is modified to 2, right? So now find the new middle position. So mid equal to 0 plus 2 divided by 2, which is equal to 1. So now compare A of mid with that of key, right? So here what is A of mid? Mid is 1, so which is 33, and key value what we are looking for is also 33. So we are done, right? So we stop here, right? Supposing we are searching for the key value, say 22, right? So new mid value what you get is 33. So 22 is less than 33. So here what you have to do is, so in this case we've already seen. So let's take this key value to be 44 and check whether this works, right? So here now let's assume that we are searching for a key value 44. So in the second pass, like we again check that is not equal. So A of mid is 33 and we are looking for 44, which is not the same, and now we find that it is greater than that of the mid value. So if the key value is greater than that of the mid value, then you have to change the low. So low will now become what? Mid plus 1. What is mid plus 1? Mid value was 1 in the previous step, so now it will be 2. So high remains the same. High is not getting changed. So high is 2, right? So now finding the middle position. So 2 plus 2 divided by 2, you get 2. So now you compare A of mid with that of key. So this is A of 2 and key is what? 44. What is A of 2? 44. 44 is equal to 44. You're done. Right? Supposing we are looking for, say for example, we are looking for 55. Key value. This is another example, right? So we are looking for the key value 45, which is not present, right? So here we'll look for the value 45. What happens here is you find that this is greater, right? key value 45 is greater. So you do the comparison here, right? So now if it's greater, then we have to change the low value. So low will become what? Mid plus 1. What is mid? It is 3. But what is high? High will not change its value, so high is 2. You could see that low crosses high. So if low crosses high, then it means that we have compared all the values in the list and the element is not found. Hope this is clear. I will summarize it in short. It is like you'll be given the list of values in sorted order, and the idea here is to divide and conquer. Just try to split the list at every step and check whether the element you are trying to search is the element in the middle position or it is in the left or right hand side of the list. So if the element is lesser than the middle value, then it should be present in the left hand side of the list. So we can simply leave the rest of the list which is occurring in the right side. Or if the element is greater than the middle value, then we have to simply skip the elements in the left hand side of the list and check or proceed with the same procedure with the remaining elements in the right hand side of the list. And the condition to stop here and say that the element is not found is when the low value crosses high. So when low is less than high, then we can understand that we have few more elements to be compared. If low crosses high or high becomes less than low, then it means that you have compared all the values and there are no elements left and compared. So we have to simply stop and say the element is not found.